Alright, so let's take a look at this problem. We've got about, excuse me, I just hit the mic. We've got about 6 problems that are similar that are multiple choice here. For each problem, they're wanting us to determine the range, the end behavior, and the y-intercept. Now, in this problem, the base here, e, is the natural number. E is an irrational number, um, very similar to pi, in the sense that it's irrational and used in an amazing number of applications and places. Your scientific calculator has an E button on it. Let's pull up the calculator. Usually you have to hit the shift key and it's on the LN, the natural log button. Here it's asking me what exponent would I like, so just to the first power. And you can see it's 2.718, and it goes on forever without any kind of a repeating pattern. So students at first, it takes a little bit to get used to it. What you prefer to see is some number like 4 raised to the x power, then plus 2. But you just have to learn to think of this e as a number, like 4, only that e is an irrational number. All right, now when we have an exponential, a basic exponential function, this e is bigger than 1, so this base is bigger than 1, and we know that a sketch of the graph would look like this, and that these basic exponential functions have a y-intercept of 1. All right, but here in this problem, there's been a transformation. See, I'm talking about what the graph of e to the x would look like. This 3 and this 2 are transformations on the y-coordinate. This 3 is a vertical stretch by a factor of 3, and this 2 is a shift up 2 units. All right, so that's going to affect the range. See, normally our range is from 0 to infinity, but if you've lifted this graph up 2 units, to where now the horizontal asymptote is the line y equals 2, your graph looks like this. This vertical stretch doesn't change the range. So the range for this function, the range is from 2 to infinity. And among our choices here, that's choice F. That R is for range. All right, so what about the end behavior? Well, we were just saying that since this base is bigger than 1, that it looks, the graph of this with this range being from 2 to infinity. On the left here, as x is approaching negative infinity, as you move to the left, the y-coordinates are getting closer and closer to this horizontal asymptote. They're getting closer and closer to the value of 2. Now up here, as you move to the right of the origin, then this graph is increasing really rapidly, and y is going to positive infinity. So if we look at the end behaviors here, as x approaches negative infinity, we're looking here is 2. As x is approaching positive infinity, y is approaching positive infinity. So this is the choice C. Now, the y-intercept. To find any y-intercept, no matter what the function is, you let x equal 0. Alright, so to find this y-intercept, we know that the x-coordinate is 0. To be on the y-axis, you haven't moved left or right. So you want to input 0 into this function. So this is 3 times e to the 0 plus 2. Well, e to the 0 power is just 1. By definition, if you have a non-zero base raised to the 0 power, that's 1. 3 times 1 is 3, and 3 plus 2 is 5. So that vertical stretch, this stretched it by a factor of 3 and lifted it up to where that new y coordinate is 0, 5. So let's find it. There it is, B. So here's our answers for problem number 13, and I hope that helps, and I'll talk to you later.